Hi, this is Mike Sweeney from AKF Engineers introducing our submission for the 2022 NYSERDA RTEM Hackathon. The purpose of the RTEM challenge is to develop a novel use case that will help accelerate the electrification and decarbonization of New York State's building stock. Judging for the hackathon was based on 5 criteria: use case description and demonstration, market adoption and impact, decarbonization through electrification, ease of implementation, and use of open data sources. After exploring the dataset, we decided it was best to show the impact of switching from fossil fuel to electric heating. Fuel switching will lead to not only an immediate decline in carbon intensity, but will yield increasing improvements as the electric grid becomes cleaner over time.
Of course, any building could be converted to heat pump heating. However, some are easier than others. Given the available data, we decided to focus on buildings with hot water distribution as the primary heating source, where the maximum water supply temperature is no greater than 140 degrees Fahrenheit. Due to current limitations, heat pumps are most effective delivering hot water less than 140 degrees. We identified this set of buildings as heat pump ready, with the idea that their hot water source could be converted to a heat pump without major mechanical and piping infrastructure change.
The first step in understanding the database's heat pump readiness was to query and analyze hot water supply temperatures for all buildings with hot water heating data points. All told, there were about 10 buildings in the dataset that would be recommended targets for in-kind heating system electrification. However, only about half of the buildings that have hot water equipment in their points list actually track hot water supply temperatures. This means we don't know how many other buildings have gas boiler heating, but don't report it. In other words, more and better data could increase the number of heat pump ready buildings and identify opportunities for different types and levels of electrification initiatives. Of the available data, we concluded that about 20% of hydronic buildings are at least somewhat heat pump ready, meaning this is a metric worthy of further exploration and refinement. AKF's proposal consists of the following items. Establish a grading system for measuring building reporting, indicating the quality and scope of points monitored. Of these buildings, identify a series of tiers for electrification viability. Develop virtual electrification cases by post-processing boiler consumption trending data and applying a virtual COP using an outdoor ambient temperature-based efficiency curve. Use Cambium projections from 2022 through 2050 to demonstrate a carbon intensity over time regression for the gas, as well as the virtual electrification case. AKF's submission is intended to be both a wish list for future analyses and a commentary on the state of the database as it currently stands. The proposal was a twofold approach that identifies electrification opportunities and estimates their potential impact as more renewables come online in New York State through 2050. This will be especially beneficial to buildings held accountable to New York City Local 197 or other future emissions regulations. Thanks for watching.